Lesson 2.9, Graphs with Decimals. This bar graph shows the women's gold medal winning long jumps at 5 Olympic Games. And when you look at this bar graph, notice the title of it first, Women's Olympic Long Jump Gold Medal Distances. And then look at how both the axes are labeled. The x-axis shows us the time dimension, in this case the Olympic year. Olympic Games happening every 4 years. And then across the y-axis, we've got the distance measured in meters. I'm going to infer that this is a running long jump, not a standing long jump, just based on what I know about the actual distances here. And I'm going to read the teacher note here. There is a bar for each Olympic year. True. The height of the bar is the jump distance in meters. Read the height on the vertical axis. For example, the top of the 2008 bar aligns with 7 400 meters on the vertical axis. The bar represents a distance of 7 400 meters. Question 1. In which years was the winning jump shortest? What was the distance of the jump? Well, visually looking at the bar graph, we can see that the year 2000 appears to have the shortest gold medal jump, and the distance of that jump appears to be smack in the middle of 6 9800ths and 7. So what is the value halfway between 6 9800ths and 7? Well, think about it. If this was a money example, $6.98 versus $7, smack in the middle would be 6 9900ths. So I'm going to say the year 2000 and 6 9900ths meters. Question 2, in which year or years was the winning jump the longest? What was the distance of the jump? Okay. This appears to be a tie, doesn't it? You see in the years 1996 and 2012, we have a winning jump of 7 1200ths meters. Question 3, how much longer was the gold medal jump in 2012 than in 2004? Okay, so in 2012, we just saw it. That was 7 1200ths meters. And in 2004, that's smack in the middle of 7 600ths and 7 800ths, so we're calling that 7 700ths. What operation do you suppose we will use here to calculate how much longer? In other words, the difference between these two jumps. If you said subtraction, I would agree. So I'm going to line up my decimal point right where it lies. 2 minus 7, the 2 needs to borrow. 12 minus 7 is 5. 0 minus 0 is 0. 7 minus 7 is 0. A very small difference between the distance of these jumps. 5/100ths of a meter. You could also call that 5 centimeters. Question 4. The 1992 women's gold medal jump was 1,500 meters longer than the 2000 jump. What was the gold medal distance in 1992? Okay, so clearly in our data in the graph, the year 1992 is not included, but we're given a clue. If we start with the distance of the jump in 2000, which is smack in the middle of 6 and 9800ths and 7. In other words, this is 6 and 9900ths. And we're told that the 92 jump was 15 meters longer than the 2000 jump. What operation are you thinking here? Well, if you said adding, I would agree with you. The 92 jump was longer. How much longer? 1500ths meters longer than this value, which was the distance of the 2000 jump. Let's add them together. Insert the decimal point right where it lies. 9 plus 5 is 14. Carry the 1. 1 and 9 is 10. 10 and 1 is 11. 1 and 6 is 7. And we get 7 and 1400ths meters. And it's interesting to notice that had that data been included, that would have actually been the longest jump out of any of these in this graph, wouldn't it?